Illustrating methods of light dispersion in the physics classroom can be challenging. When it comes to demonstrating the separation and dispersion of light into colors according to their wavelengths, teachers usually have a choice of two methods. A prism accomplishes this through the principle of refraction. Different wavelengths of light travel at different speeds through a transparent material, which cause them to bend at different angles. On the other hand, a diffraction grating produces overlapping waves of light that interfere, producing a pattern of bright constructive points of light and dark destructive regions. The bicolored laser produces two parallel laser beams, either simultaneously or individually, one red and the other green. When projecting the two beams through the prism, students can easily see and measure the amount of refraction for each colored beam. Since more refraction or bending occurs with the green laser beam, it must have slowed more passing through the prism due to its higher frequency and shorter wavelength. Building upon this demonstration, we can better understand how each color making up white light can be separated into a complete spectrum. When using the diffraction grating, the constructive points of light that are formed spread farther apart as the wavelength increases. This results in the spacing of the longer red wavelength points of light to be further apart than the green points of light. In addition to demonstrating red light's longer wavelength, careful measurements of the interference pattern makes it possible to calculate the wavelength of each color. This dual-colored laser is a fun tool to demonstrate the separation and dispersion of different wavelengths of light.